Let us start. So today we will discuss the few problems related to the arbitrary rolling or the non-harmonic loading kind of problems we will do. So in this we will solve some problem related to the step function, some problems related to the triangular, and some problems related to the sine like the half sine pulse. So we will discuss those kind of problems, so that will be helpful uh, for solving your sorry, your assignments. So let us start. I will share my screen. So so is my screen is visible?
Yes, a small screen is visible, but it needs full screen.
Now it's visible, I think.
No, it is a small screen.
From my side the whole screen is visible uh, for the whatever I will write on the pad. Some other student also facing the same issue.
We are able to see actually.
Okay, thank you. So let us start. So, like initially two questions, like we are solving some like the basic questions which you might be know. So but for the reference, for the reference to the other students, it would be better to start from the some basics. So in the first question we have a step force. So we need to find out response corresponding to step force. So to find out the response corresponding to the forces, we have done the solution in the equation like mu double dot plus ku is equal to p. So for this kind of equation, this is also a kind of step force. Okay. So for this kind of problems, we have the solution already. Like how what was the solution? Ut is equal to a cos omega t b sine omega t plus p by k was the solution for the this equation. And if we will find out the coefficients a and b, so you can find out by using a0 and u dot 0. So first if we do for that u0, so that becomes a plus p by k. And if I do the u dot t, then it becomes a omega n sine omega n t plus b omega n cos omega n t plus 0. So if I will put it u dot 0, so that term will become 0. So only this term will remain b omega n. So from here my p becomes u dot 0 divided by omega n. So if I will put it in the equation ut, it becomes I can put a as a u naught minus p by k into cos omega n t plus b I can put u naught t by omega n sine omega n t plus p by k. If I will take, if I have the initial conditions, let us suppose u is equal to 0 and u dot 0 is equal to 0, then my solution will become ut is equal to p by k into 1 minus cos omega t. Okay, that was the solution from this. So for this kind of solution directly we can get from the Duhamel integration. So the representation, the equation for the Duhamel integration, ut is given by 1 by m omega n 0 to t p tau sine omega n t minus tau d tau. So actually this expression is already this expression is already covered, like by u 0 and u dot 0 is equal to 0 is covered in this equation. So if I will put p tau is equal to p naught or whatever the p we have force. So for this, if I write it 1 over m omega n 0 to t p sine omega n t minus tau d tau, and if I will do the integral of this m omega n, so that becomes p naught minus cos omega n t minus tau divided by minus omega n 0 to t. Okay, if I will substitute the limits, finally I will get the answer as a p by k into 1 minus cos omega n t. So from this I directly found out the solution. So like in this, for the simple system like this step kind of function, over this solution was also is okay, not so much problematic. But instead of the step function, if we have some sort of another function, let us suppose you have rise time, then straight, then lower. So in that case, by using Duhamel integral, you can find out the solution very easily. Okay, so the Duhamel integral is not nothing new, it is only a technique or is a simpler way to find out the solution of the equation, like solution for the different type of the problems. So is there any doubt in this question, anyone? This was just a derivation. If not, let us go to the next question. So can you tell me, for the rising force, what is the expression for the Duhamel integral?
It will vary in proportion to T by TR.
Yes, so in this case my p tau will becomes p naught by tr into t or tau, whatever it is in terms of the tau, it will be tau or t would be tau. So that is the things, and for this I will replace my value in this 1 over m omega n 0 to t, and for the p tau I will replace p naught tau over tr sine omega n t minus tau into d tau. So that is the case, so you can solve it. So this is the for the phase 1. For the phase 2, after tr, your vibration will be the free vibration. So for this, your equation would be the ut would be a cos omega n t minus tr b sine omega n t minus tr, and then these coefficients u, what we say u, use your u dot t, sorry not dot, that would be utr, and then b would be u dot tr divided by omega n. Okay, simple, you can calculate it. So from this you can directly calculate the response. Okay, so these are the simple basic questions. So now we are moving some mathematical problems. using the formulation which you have already available. So in this problem, we have given a one story frame is modeled as a 4-meter height frame with two steel column hinge at the base, and the rigid beam has natural fric period is the zero point 0.5 second. Okay, so the frame, we have given the time period of the frame. Each column has a moment of inertia, MOI is 2772 centimeter power 4, and the section modulus is 252 centimeter cube, and the elastic modulus is, as we know, 200 into 10 raised to power 9 for the steel. So a rectangular impulse of amplitude 20 kilonewton. So a rectangular impulse of 20 kilonewton is applied with a duration TD is equal to zero point 0.2 second.
Sorry to disturb you, sir.
Yes, is there
This
any?
problem has already done in weekly course. The videos. This problem has done.
If this problem has done,
Yes, yes, completely.
so if some of them has not gone through, then
Okay,
for the others we can go for this.
okay, okay, sir.
Okay. So for this, we need to find out the we need to find out the displacement at the top of the frame u naught, and we need to find out bending stress sigma b in the column. So this kind of problems in which we have done like the how to find out the stiffness and all we have done. So first find out the stiffness of the system. So for this, for the pin supported for the one column, my stiffness would be 3 ei by l cube. So for the whole stiffness k would be the 2 time k1. So this will become 6 ei by l cube. So that would be 6 time E is 200 into 10 raised to power 9. I is 2772 into 10 raised to power minus 8 divided by 4 cube. So can you find out the stiffness? Can you find out the stiffness for this problem? What is K?
It is 520 kilonewton per meter.
So if you will be like
519750.
okay, so that is the 519750 Newton per meter. So we can write it 519.75 kilonewton meter either. So for this, we have now we can find out the time period. We have given the time period Tn is equal to zero point 0.5 second we have given, and Td is given us the zero point 0.2 second. So for the rectangular pulse, whether my response maximum response would be during the free vibration or the force vibration, I need to find out the Td by Tn ratio. So what is the Td by Tn ratio? This zero point 0.2 divided by zero point 0.5, so that will comes out to be zero point 0.4. So for the rectangular pulse, Rd is given as 2 sine pi Td by Tn, and 2 if Td by Tn is less than or equal to 1 by 2, and if Td by Tn is greater than or equal to 1 by 2, then Rd is 2. So in this case, our Td by Tn is less than zero point 0.5, so our Rd would be given by 2 sine pi Td by Tn. So can you calculate the Rd value for me? Anyone with the RD value?
Actually, I have a doubt.
Yes.
Uh, in the RD, TD by TN is less than 1 by 2. You have written, right?
Yes.
Actually, in our videos, Sarah has told me like less than equal 0.25.
No, no, that is the different thing. If your TD by TN is less than 0.25, then your impulse is considered as a, like, the area of shape of the impulse doesn't affect. That was the different thing. This is a 1 by 2. There is no doubt in this.
Because actually, this problem solved by Sar in videos,
Yes.
he is also compared with 0.25 only. That's why I'm asking.
No, that should be the point 0.5, not the 0.25.
Okay, okay. Thank you.
So in the class, you have compared with the TD by TN is less than 0.25 or greater than 0.25. Is it?
In class only, Sar told 0.5, but in problem solving, it is compared with 0.25.
So that was the different problem, might be due to, in that they have considered the area of the impulse. That kind of thing was there.
No, no, same. Similarly, what you have, what you have done here, same similar thing.
But no, here it should be zero point 0.5, not the
Okay,
0.25.
okay.
So if you find RD using this, your RD will comes out to be around 1.902. Okay. So if those things you will use RD, now you have a RT, so now you can calculate the deflection in the A. How the deflection is given? U naught is P naught by K into RD. So P naught is given to you 20 kilonewton. K we have calculated as 519 519,750, and RD you have getting 1.902. So if you will solve this, you will get 0.073 meter, or you can say 73 mm. And in the B, you need to find out the stress. So for finding out the stress, you need to find out the force, which would be K into U. So that would be 3 EI by L cube into U naught. So moment you can calculate F into L. So that would be 3 EI by L square into U naught. Okay. So if you will put, you can find out the what is the moment you are getting. 3 into 200 10 raised to power 9. I is your 2772 into 10 raised to power minus 8. L is your 4 square, and U is your 0.073. Okay. If you will put it, you will calculate moment is equal to 75987 Newton meter. So the bending stress, can you calculate it? M by Z. Anyone? So that will become around 301 ampere. Okay. Any doubt in this question? Anyone? If not, then let us move to the next question. Is this kind of problem also done? That same problem or the different one?
Yeah, it is different. I think this is the diagram is
Lo-
triangular
Loading
there.
was different.
Yes, yes. Loading was different.
Okay. So in this problem, you have given a water tank which is treated as a single degree of freedom system structure with the following properties. The mass at the top of the water tank is given as a 700,000 kilogram. Stiffness is given to you as a 7,000 kilonewton meter. So as a result of explosion, the tank is subject to the dynamic load history as shown in the figure. Now compute the approximate maximum overturning moment at the base of the tower. So for the finding out the moment, you need to calculate like what is the my displacement at the top, you know. So in this, first find out the time period. Can you find out the time period? So the mass is given to you, and the stiffness is, so can someone find out the time period?
It is 20 pi.
25.
20 pi. That is 62.83.
62.83 watt.
Sorry, 1 minute. 1.986.
Okay, so you are getting 1.986. Also, because omega 1 will be used further, so please find out the omega n also.
3.163.
Okay, so 3.163 radian per second. So find out my total time duration for this TD is how much? 0.2 is the TD. So find out TD by TN. 0.2 divided by 1.986. What will be this ratio?
0.1.
Point one.
So you are getting zero point 0.1. So if you remember during the class, if my TD by TN is less than 0.25, then the shape of impulse or pulse doesn't affect my response. So my response for the undamped vibration ut can be given as I by m omega n sine omega t. Okay, so where I is the pulse area, which we call PDT, 0 to t. So can you find out me the pulse area? I simplify this, consider this one as a triangle, simple. This one you can consider as a trapezoidal. Then this one is also trapezoidal. Then this one also triangle. So can you give me the value of I, like the area of loading curve, so that we can find out the response? So here I have shown you the let me zoom it so that you can find out your maximum zoom. Okay.
It is 22 kilonewton second.
Okay. So you are getting 22 kilonewtons a second. Let us solve here. So that is coming. I is equal to first is like the diagram is like this one. Then it is going this way. Then it is going this one, and then it is coming to downward. Okay. So the amplitude and the is the 155, 220, and 65. 155, 220, and 65. So the first term is first, second, third, fourth. The first one is the 1 by 2, 155 into 0.05. Now the second one is the 155 plus 220 divided by 2 into 0.05. The third one would be 220 plus 65 divided by 2 into 0.05. And the fourth one is the 1 by 2 into 65 into 0.05. So if you will get someone calculated the I is equal to 22 kilonewton, sorry, kilonewton second. Okay. Now if you go to the I, you can find out the U naught I by m omega n maximum response. So find out this. Find out this. Anyone with the maximum response?
It is 9.93 mm.
Yeah, I am getting 9.945 10 raised to power minus 3 meter, or whatever you are getting in the mm. Now I have the displacement. So now I can find out the my force or the moment. So the force would be F into K times U naught. So K is given to you as a 7,000, and the U naught is given as a 9.945 into 10 raised to power minus 3. Okay, so you can find out the force. So the force I am getting is coming out to be 69.6 kilonewton. So the moment will generate at the bottom would be F time H. So that would be 69.62 into H is 45. So I am getting the moment is equal to 3132.9 kilonewton meter. Okay, any doubt in this problem? Anyone? Okay, if not, now let us move to another problem.
This previous problem, uh, is there something like inverted pendulum we have to consider, and then
Invert
we have to consider in case the mass is given of the no, the supporting structure, it has to be considered. No,
mass of the
in case of in case of inverted pendulum, one third of the mass of the supporting member to be considered at the top. Correct? No, in case if it is given.
no for what inverter damper or inverter.
No, no, for the structure, supporting structure between the support and the between the ground and the
Yeah,
top.
that was the m by 3. Yes.
That's what I'm.
So now in the question 5, we have given a single story building which is subjected to a blast induced pressure wave as shown in the diagram. The building may be modeled as a single degree of freedom with the K is the 11,000 kilonewton per meter and the weight or the mass of the building is given as a 50,000 kilogram. In this case, the damping is also given to us. Okay, keep in the mind damping because that will be like there's some sort of use in the last. So the pressure may be presented in the equation in terms of the equation P is equal to 7 e raised to power minus 53. So the pressure is given as a, let me write it, 7 into e raised to power minus 50 t minus e raised to power minus 200 t. Okay, so this is the pressure is given to us. Okay, so we need to find out, and the building area which is subjected to the pressure is the 14 meter square. So we need to find out the peak displacement in the column and the shear forces in the column. So first find out the time period of the building. So can you give me the time period? Anyone?
13.39.
How much?
13.39. No, no,
13.39 is the time period.
no, no, sorry. Wrong.
0.423.
So you are getting time period as a 0.423 second. Okay, and the time duration is given as a TD. So you can see this, the time duration TD is 100 millisecond. So what is the TD my 100 millisecond mean the zero point 0.1 second. Okay, so what is my TD by TN?
0.236.
0.236.
So my time period is TD by TN is 0.236. So which is less than 0.25 means my shape doesn't affect the response and the response is given by ut is equal to e I by m omega n e raised to power minus xi omega n t.
What is this 0.25?
0.25 is the for the if my td by tn is less than 0.25, means my shape of the like the any pulse doesn't affect. Like I can take consider the directly area of the pulse to find out the response. Like as we have done in the previous question also same.
Okay, it's a standard value, constant value, 0.25.
Yeah, it is like approximation. Like if
Okay,
if the td by tn is less than 0.25, then our response will not affect by the shape of the pulse. Then we will
okay,
take the directly the area of the pulse.
okay.
So the my response is given by sine omega and t. Here actually our damping is very small, like 5%. So our omega n we are considering nearly omega d. Okay. So we need to find out the maximum response for this. So to find out the maximum response at what time, what would be my maximum response for the damped system? So how do we find out the maximum response from this expression? Anyone?
You may have to differentiate.
Yes, we need to differentiate. So to do the differentiation so that we can find out the maximum response u dot t and do it equated to 0. So for this, if I will equate it to 0, I will get cos omega n t is equal to xi sine omega n t. So I can write it as a tan omega n t is equal to 1 by xi. Okay. So my t would be maximum for this 1 by omega n tan inverse over 1 over xi. Is it okay? So can you find out what is the t value at which my maximum my response would be the maximum? Give me the t value.
It's 5.866.
5.866. Keep in mind that your calculator should be in the radian. Omega is in omega, and you know
Yeah, 2 pi by Tn.
2 pi by Tn. So your omega n would be 2 pi by Tn. So your Tn is 0.423. So your omega 1 would be coming out to be 14.83 radian per second. Okay, so now for the time period t is equal to 1 by 14.83 tan inverse 1 over 0.05. Anyone? Anyone with the answer?
Is it 0.102?
Yes. So it is coming out to be 0.1025 second. So at that time my response would be the maximum. Okay. So what I need to do, I need to put my value in this ut. So now for the putting the value of in the ut, I need to find out the first I, and I is the what, area of the curve. So 0 to 0.17 into e raised to power minus 50 minus 50t minus e raised to power minus 200t. Can you get me the value of I so that I can put into the equation? Anyone with the I? Anyone with the I?
It is 0.104.
Yes. So it is coming out to be 0.10405 kilonewton per meter square, or I can write it as a 104.05 newton meter square. So at what area it is applied, that is a newton second also, no, not only the, because, so at what area it is applied, 14 meter square. So my total impulse of the area, it would be the 104.05 times the 14. So that will give me the 1456.8 newton. Okay. So now my response u naught would be I by m omega n e raised to power minus xi omega n t sine omega n t would become, I is given to us 1456.8, m is given to you how much, 50,000, omega n do you have 14.83, damping you have 0.05, omega n 14.83, t at what point you will get the maximum, that would be a 0.1025, and then sine omega n t. So sine omega n is the 14.83 and t is 0.1025. Okay, so can you get me the u naught? Maximum response of the system?
14.84 into 10 raised to power minus 5, 4.84.
No. Yeah, keep in mind that it should be in the radian. Sine 14.83 into this, either you convert it into the degree, then you can keep your calculator in the degree form, or either if you will keep your input value of the angle in the radian, then keep it directly.
Sir, is it 1.82
Yes, 1.82 watt unit. Can you tell me the units?
into 10 raised to minus 3 meter?
Yes. Is it okay? Let me. So it is coming out to be 1.8185 around 10 raised to power minus 3 meter, or I can write it into the 1.818 mm. So this is my first part, like what is my peak displacement of the column. Now I need to find out the peak shear force in the building, or the peak shear force in the column, single column. Part B, peak shear force in the column. So can you tell me how we get the peak shear force? How do we get the value of the force? Anyone? Because we have shown too many examples
It's
related
K into peak
x.
displacement.
Okay, you are saying k into x, but not the, because whatever we have done k into x, those were the undamped system. Okay, if my system is damped, my force would be the k into x or k into u, whatever, plus c into x naught for the whole building, or for the one column it would be 1 by 2. Okay,
Yes.
so here I can represent it either this one, or I can calculate mx double dot by 2. That is okay.
Mx double dot.
Like initially what was my equation, like mu double dot plus ku is equal to 0. So I can find out the force, either k is ku or either mu double dot, this way.
Yes. Correct,
So in
correct.
this way, either this one or this one. So we are using the force or the shear in the, that will be the mx double dot into 2. So my x double dot how much, that would be the omega n square time u naught. So give me the final value, like 1 by 2 into mass into omega n square into u naught. Okay, so put the values as you have given. The mass is equal to 50,000, omega n is the 14.83. U naught you have calculated 1.818 mm. So give me the shear force in the column.
Ten into 10 power 6.
10 into 10 raised to power 6. How much is it in the? Please keep in mind U naught in the mm. If you divide by 1000, you will get the your answer, I think. So I am getting 995 Newton, or some of you might getting 10,000. Is it okay?
Yes, okay.
So anyone has any doubt in this question? Anyone related to this or the previous questions? Because the next question we are going, which is very long, that might take around 20 or 25 minutes, because that is the derivation kind of thing for the triangle pulse. So okay, let us move to the next question, which is very long. Actually, in this we don't have the expression for this triangular impulse. Like we have the curves. So how do we got those things for the triangular impulse maximum response? So that's why it will take time. So we need to find out the, like, using the Duhamel integral or something else. We need to find out the response of a single degree of freedom system to a blast loading specified by the triangular pulse shown in the figure. So we need to find out first what is the response if the my system is initially at rest, like u is equal to 0, u and u dot is equal to 0. So that is the one thing we need to find out. After that, we need to find out the maximum response, like the rd, like how at what time period, at what t my rd would be maximum. And then using those things, my part c will become small then. Okay. So first, let us leave it and then go it one by one. Like part C, we will discuss in the end. So we have given the impulse at TD and P naught. So how can I write it? Can you tell me the function of PT? How can I write?
This P into 1 minus.
Yes, that would be P into 1 minus T over TD. Is it okay?
Yes, yes.
So my PT would be 2. That is the one is the P naught into 1 minus T over TD for T is less than TD, and it would be 0 if my T is greater than or equal to TD. Okay, this is the my PT expression. So now the consider the case T is equal to less than TD. For this, my PT, or if I will say P tau, will become as a p naught 1 minus tau over td. So by the Duhamel integral 1 over m omega n 0 to t p tau sine omega n t minus tau d tau. So if I will put the value in this 0 to t p naught t minus tau over, not the t, 1 minus tau over td into sine omega n t minus tau into d tau. So I will rearrange the terms, so that will be easy for us to do the integral p naught by m omega n is equal to 0 to t. So that if I will rearrange this, that will become sine omega n t minus tau. One term is this, then the another term is the minus tau over td into sine omega n t minus tau. So we need to integrate this d tau. Okay. If we integrate it, please integrate it. If I integrate sine omega and t minus tau, so I will get it cos omega n t minus tau divided by omega n. Okay, or either this one, that would be same, minus 1 upon td into tau cos omega n t minus tau divided by omega n.
We are deriving for u of t, right?
What?
We are deriving this for u of t.
Yes.
There you are writing I.
Yeah, u of t. That would be u of t, not the I. Okay. Thanks for the u of t, u of t, u of t. And then it will become sine omega n t minus tau divided by omega n square. And the limit would be 0 to t. So please apply the limits and give me the final expression. If you will apply the limits to this, what would be the final expression? Like initial, that would be the p naught by m omega n. What would be the in the bracket? Please try. Anyone? Anyone with the expression? So I'm getting this 1 minus
T by TD.
cos omega and t minus t by td plus sine omega and t omega and td. Is it correct? Are you getting same?
Yes.
Okay, if I will take omega and outside, if I will take omega and outside, so it will become p naught by k, and that inside this it will become, no, it was the already outside omega and square. Okay, so if I will write it same 1 minus cos omega and t minus t by td plus sine omega and t over omega and td. So that is the response for my t is less than td. Okay, now I want to find the response if t is greater than td. So for this, my p tau is 0. So the only the case of that free vibration case would be there. So for this, ut would be u dot td cos omega and t minus td plus u dot td over omega n sine omega and t minus td. So can you calculate utd and u dot td? So in this equation, we need to put the td. So please put the td and find out those things. So if I will put td in the equation, I will get p naught by k 1 minus cos omega and td by td plus sine omega and td over omega and td. So that would be 1, so that will cancel out. So my this will become as a p naught by k into sine omega and td over omega and td minus cos omega and td. Is it okay? So to find out the u dot td, first find out the u dot t. So if I will get the u dot t, which will comes out to be p naught by k into omega n sine omega and t minus 1 by t plus cos omega and t over td. And if I will put t is equal to td, I will get it p naught by k omega n sine omega and td 1 upon td plus cos omega and td over td. Now I will put this value in this equation. So after putting these value in the equation, my final equation would be ut equal to p naught by k 1 over omega and td into 1 minus cos omega and td into sin omega and td t minus omega and td minus sin omega and td into cos omega and t. So this is my response in the phase 2. So that is my part A complete. Like expression for the t is less than td and the t is greater than td. So now I need to find out at what value of t what is the my maximum response. Okay. So the now we need to calculate the in the part B maximum response. So for the first part t is less than td, my ut was, I will write it here, p naught by k into 1 minus cos omega and t minus t over td plus sin omega and t by omega and td. Okay. So this thing I can write it as a rd. So I need to find out at what is the expression for the maximum rd. 1 minus cos omega and t over td plus sin omega and t over omega and td. So for finding out the maximum response, I need to find out the derivative of this corresponding to dt. So can you do that? This is the very simple case. Do the derivative of this. If you do this, you will find out this omega n sin omega n t 1 over td plus cos omega n t over td, which I put is equal to 0. If I will put it equal to 0, then I can rewrite this equation as a omega n sin omega n t is equal to 1 minus cos omega n t over td. Or I can again write this equation as a again omega n td sin omega n t is equal to what I can write 1 minus cos omega n t, I can write it as a 2 sin square omega n t over t 2. Okay. And along with that, I can this term also I can write omega n td into 2 sin omega n t by 2 cos omega n t by 2 is equal to 2 sin square omega n t by 2. The 2 will cancel out, sin omega 1 term will cancel out, so I will get omega n td is equal to tan omega n t by 2. This is, so what is my t, or omega n t by 2 would become tan inverse omega and td. So I can find out the, because I need to put the value of t in this expression, omega and t, this one. So I can do it in different way also. Okay, so let I am considering, let u is equal to omega and t by 2, and x is equal to omega and td, so that u will become as a tan inverse of x. So from this I can write as a sin u as a x over 1 plus x square, and cos u is 1 over 1 plus x square. So sin u is what? So if I will put these value into this equation, cos omega and t, sin omega and t, then I will get it. So now my RD is 1 minus cos omega and t minus t by td plus sin omega and t over omega and td. So I can rewrite it 1 minus 2 cos square omega and t by 2 plus 1 plus 1 minus omega and td into 2 sin omega and t by 2 and cos omega and t by 2. So now I can put the sin and cos value from this. So I can write it like that: 1 minus 2 cos square u plus 1 plus 1 upon omega and td into 2 sin u cos u. And if I will put the value of sin u and cos u, the final value I will get my RD as a 2 minus 2 tan inverse omega and td over omega and td. This I will get, or simplify I can write it as a 2 pi by tn. So this simplified I can get it 2 minus tn over pi by td into tan inverse over omega and td. So that is the response, maximum response for the force vibration. And for the case 2, t is greater than td, can you directly tell me from this expression what will be my maximum response? Anyone?
2.
Not 2. This equation, if you look carefully, if you look into this equation look like p naught by k some factor a multiply sin omega t plus some factor b cos omega t. So we can write the response, maximum response, directly: a square plus b square. Is it okay?
Yes, yes.
So from for the free vibration phase, our maximum response we can directly get it from this equation. So for this, my maximum RD will become 1 over omega and td is equal to 1 minus cos omega and td square plus omega and td minus sin omega and td square. So this is the my maximum response for the phase second. So that is the final thing. Now we need to move part 3 so that we can find out the response whatever the response it is asked. So if that plot is like the that r is plotted with the td by tn and r, then you will get a curve like this one, and one is like for the free vibration you will get this one. Okay, so for this value is td by t1 is 0.371. If you will plot in the excel, you will find if your td by tn is less than or equal to 0.371, then your maximum response would be during free vibration. And if your td by tn is greater than 0.371, then your maximum response during force vibration. One thing is that either if you don't know what the 0.371, then you calculate the RD for the both the cases, then you will get automatically RD for whatever the case. Other, if you don't remember those things, 0.371, is it okay? You have the expression for the maximum RD for the both the cases, put the TD by TN value, and then find out whichever is coming out to be maximum will be your response. So now let us move to the part C. So in the part C, you have given a stiffness of the system K is given to you 9 into 10 raised to power 9 Newton per meter. Mass is given to you 10 raised to power 7 kg. So you need to determine what is the maximum blast force P naught that can be sustained if the displacement is limited, if the maximum displacement U naught is limited to the 5 mm. Okay, so what is our U naught is given? U naught is P naught by K into RD. RD we can find out, U naught is with us, K is there, so we can find out the P naught directly. Okay, so for this, first find out the Tn, time period of the system. Let me write these data to there so that it won't be difficult for you. K is given to you as a 9 into 10 raised to power 9 Newton per meter. Mass is given to you 10 raised to power 7 kg, and U naught is given to you 5 mm. So we need to find out the P naught. Okay, so first find out the Tn. Can anyone give me the Tn? Anyone? Please try to. I know you will get bored during that derivation, but that will be helpful for your in some another exam or somewhere, that how to get the maximum response.
0.209.
Yes, so your Tn would be 2 pi 10 raised to power 7 into 9 into 10 raised to power 9, so we are getting 0.2094 second. So now our TD is given us, TD is given in the question itself, like we have two cases A and B. Okay, so for the first case we have given two TD, one is the 0.4 second, one is 0.04 second. Okay, so first let us consider TD is equal to zero point 0.4 second. So my TD by TN, what will be my TD by TN? 0.4 divided by 0.2094, that will be coming around 1.91. So my maximum response, if my TD by TN is greater than 0.371, my maximum response during the force vibration. Okay, so for this my RD is given to you as 2 minus Tn over pi into Td into tan inverse omega and Td. So please give me the RD for this. Can you give me the value of RD? Omega n also you can calculate. 2 pi by Tn. So that I am getting around 30 radian per second. So you have omega n, you have Td, you have Tn, you have pi Td. So can you get me the RD? Keep in mind, keep your calculator in the radian so that your tan inverse omega and Td you can keep in the radian.
One 1.75.
Yes, it is coming out to be 1.75. So if you will put 2 minus Tn is 0.2094 pi zero point 0.4 tan inverse omega n is that 30, Td is zero point 0.4, so you will get 1.752. So now you have RD, so you can get U naught into P naught by K into RD. So U naught is given to you 5 mm, so that will be 10 raised to power 3. P naught K is given to you 9 into 10 raised to power 9, and RD is 1.752. Can you get me the P naught? Anyone? What would be my P naught so that my structure can sustain the blast? Is anyone with the answer?
25.68 into 10 power 6.
How much?
25.68 into 10 power 6.
In what? Newton?
Yes, newtons.
Yes.
So I am getting here 25,714.3 kilonewton. Okay, that was in the Newton. So here I am getting this one. So now in the case 2, if my TD is 0.04 second. Can you calculate TD by TN ratio? So that will be simple 0.191, which is less than 0.371. So the my maximum response would be during free vibration. So for the free vibration, what is my RD is 1 by omega and TD, omega and TD square root 1 minus cos omega and TD square plus omega and TD minus sine omega and TD square. Can you give me the RD for this by using this formulation? You have omega n as a 30 second, 30 radian per second. You have TD 0.04 second. Then you can get it directly. So please try to give me the answer. So if I will keep, let me put the values inside.
Is it coming 0.912?
No, please check your calculations. Anyone with the answer? Keep your calculator in the radian so that it would be. So I am getting it 0.576. Anyone with the answer?
Yes, sir. Yes, sir.
Okay. So we have RD. Now you can again find out your P naught. So U naught is given as a 5 mm. So that would be U naught into P naught by K into RD. So our U naught is 5 into 10 raised to power minus 3. P naught K would be 9 into 10 raised to power 9 into RD is 0.576. Please give me the P naught.
781.25.
Okay. So I am getting 78125 kilometer. So is there any doubt in this question?
Sir, I have a doubt. Can you please clarify regarding we have done previously TD by TN less than 0.25, right?
Yes.
Can you please explain this 0.371 and 0.25? What is the difference?
That 0.37 is not like, if you will plot, like, forget about, let us suppose forget about the what we say, 0.37. You find out the RD with using force vibration as well as the free vibration.
Okay.
Okay, and then you will find, like, if my RD is less than 0.371, my response would be during this, the force free vibration. You can try it with, actually you are saying if we compare it 0.25, then you can find out this I by m omega n. Try with that whether you are able to find out the u naught or not. Are you saying this now?
Yes, yes, yes. Correct. Because actually, this is for a triangular blast loading, right?
Yes, so
You
I by
see,
m omega n. Okay, so I is given your p naught into td, because m into omega n, and u naught is given to you 5 into 10 raised to power minus 3. So p naught td is given to you 0.04, m is given to you 10 raised to power 7, and omega n is 30, is equal to 5 into 10 raised to power minus 3. So let us calculate what is the difference is coming. So that would be the 1 by 2. Okay,
yes,
I.
yes. That is my doubt. Yeah, right, right.
So that p naught will coming out to be 75,000. Okay,
Correct.
so then
Yes.
you can compare it also, like these are near, because
Yeah.
that 0.25 is the approximate, because some complex, like for the, like we have get the solution for this, but there are some sort of complex type of loading, so we are not able to find out the solution.
Okay, okay.
So for that we use this approximation 0.25.
Okay, okay, yes, but in our problems, suppose in our assignment problems or our end semester exam problem, also we have to uh, remind, remember, right?
That if in the most of the problems, like in the your exam paper as well as your assignments, they given the range to you with this kind of that, if you will calculate by with any of the two method, you will get the answer, like your answer will fall down in that range. So they kept that range itself like that, so that your answer would be, if you will calculate by both of them, you will get the marks.
Okay, okay, okay. That is good.
So
Great.
that's,
Great.
so that's how the things will be set up.
Yeah. Thank you.
So is there anyone has any doubt in this question? That was actually nice, like a good doubt. Like if we have given that td by tn is less than 0.25, why do we need to go that response? But that is okay, we compared it here, and that is also we can look into the example, like we are getting nearly same, like within a, how much difference is 2% or 3%, that much of difference is there.
But suppose it is like 0.371, right, for a blast loading.
Yes,
Suppose if you got TD by TN value less than like TD by TN value 0.4, for example.
td by tn is 0.4. Okay.
Yes,
Okay.
it is greater than 0.371, right?
Yes, then you need to follow the free vibration phase, then you need to follow the whatever procedure we have done.
Suppose, for example, TD by TN value 0.3, for example.
Yes,
In that case, it is
Then
greater than 0.25 but less than 0.371.
so then you need to follow the whatever procedure we are using, this one, this RD.
Yes, yes.
This will
Okay.
applicable only, like this is like a good observation from your side. Like for the less than 0.25 you will be get the answer like that.
Okay.
So that's the good thing. But if it is higher than, like we have done the for the all the cases, not the for the 0.25, it our case is point 0.3, then we need to use this.
Can we say can it is compulsory 0.25
Yes,
because
yes, yes, yes. Like
okay, in
because
our
this is
section,
the extreme limit, like we are going approximation with the 0.25, you can see how much like we are getting around 4% variation. If you
yes,
will
yes.
go the 30% point 0.3, then the variation would be higher.
Yeah, yeah. Okay. Can I directly in our assignment also? Can I directly compare with 0.25? Okay. No, it's okay. For instance,
Okay.
uh, uh, forget about this shape of the loading. Can I
Yes.
take directly 0.25 and if I get the answer for a 0.25, it will
Yes.
be correct, right? In our
Yeah, but
assignment.
I think in the assignments everything is like that. In this, there is nothing confusion for this 0.25, and then I will look into this if there is any question how the range they have set up, because I don't know like how they set up the range. But in the exams they set up like that. In the assignment also they kept a range like this, so that you
Okay.
can get your answer. So you can try with the 0.25 as well as the whatever you are getting. So then compare it whether you are getting within the 5% range or not.
Okay. Okay.
Like it should not be variation, higher variation. Okay.
Okay. Thank you.
So now we have a like now the simple question. Like we have two more questions, but we will solve this one because the next one is only the derivation. So that you need not to go through because that is the simple mathematical. So I will explain that in the like simple way. So now a vehicle, like same kind of problems we have done during the transmissibility kind of things. So in this we have as a vehicle which mass is 1800 kg and stiffness is the 140 kilonewton meter and the damping is zero point 0.4. Okay, so first find like that is moving across a like uh, on the road it is moving, but due to some breaker or something else there is a some sort of like the uh, vibration in the system. So that we idealize as a half sine pulse, that system, like our response, like our system, like our mass, then damper, stiffness, and that is encountered during a half sine pulse, which maximum amplitude is given to us 0.15 meter, and the length of this breaker is given as a 1 meter. Okay, so how much time td can we calculate? So td would be L over V. Okay, so we have given the speed, different speed. So at speed v is equal to 10 kilometer per hour, and one is the 20 kilometer per hour. So for this TD would be L by V 1 over 10, and for this L by V is the 1 by 20. Okay, so 10 you can convert into 5 by 18 multiply to meter per second. So how much TD I am getting? 0.36 second, and that is 0.18 second. Okay, so now calculate the Tn, time period of the system. Can you give me the time period? M by K. M is 1800, K is 114 to 10 raised to power 9, not 10 raised to power 3. So can you give me the Tn? Anyone? This is the question for the half sine pulse. So for the half sine pulse, we have the curve given for the damping, because we have the solution for the undamp. For the damping we have given the curve, so we will utilize that. So first find out the time period of the system, Tn. Can you give me the time period?
Point 712.
Okay, it is coming out to be 0.712. So now I can calculate the, for v is equal to 10 kilometer per hour and 20 kilometer per hour, my Td by Tn for both the cases. So that Td is how much? 0.36 divided by 0.712, and for this 0.18 divided by 0.712. So if you do this, how much you are getting? I am getting around 0.505 and 0.252. Okay, so now you have the Td by Tn is 0.505 and 0.252. So now corresponding to this Rd, for this response for this shock spectra, Td by Tn versus the Rd for the damping is equal to zero point 0.4. So at the 0.505 nearly this, and one is the 0.25 around this 0.252. So we are getting Rd is equal to 0.957, and for this we are getting 0.574. So now using this Rd, we need to find out the maximum response of the vehicle. So the vertical ground motion is given as Ug naught is given as a Ugt is Ug naught sine omega t, and what is by omega? Pi by Td, and Ug naught is 0.15 meter is given the ramp, that is the Ug naught 0.15, this one, sine pi t upon Td. So the solution of this, U maximum is come out to be P naught by K into Rd, and for the ground excitation we are giving the ground excitation. So P naught what was? Minus mug double dot t. So ug double dot t would be 0.15 negative pi over td square into sine pi t over td. So our P naught will become m into 0.15 into pi over td square sine pi t over td. So for maximum response we took it to 1, so that u max we can write it as a m into 0.15 into pi over td square, and k we can write it m omega n square into Rd we have already. So this will cancel out. Okay, so that will be the zero point 0.5, and one is that omega n we can also write it as a omega n square as a 4 pi square over Tn square. So that is 0.15 pi square over 4 pi square into Td square into Tn square into Rd. So that will cancel out. So if I will simplify it, I will write it as a 0.0375 into Tn over Td square into Rd. So now you can find out the maximum displacement. You have Tn, you have Td, you have Rd. So for one case, 10 and 20, your Rd was the 0.957, and for this that was the 0.574. If we will utilize Umax as Td by Tn was the 0.36 and 0.18. So can you get me the Umax for both the cases? Let's try to find out. मैं हॉस्टल हूँ सर। हाँ, क्या हुआ? डिपार्टमेंट अभी लेक्चर है। क्यों, कोई काम था क्या? नहीं नहीं, काम कहाँ, यहाँ हॉस्टल में? हाँ तो आ जाओ। हाँ, आप खाना खा के आ जाओ, फिर डिपार्टमेंट तो मैं थोड़ा लेट जाऊँगा। आप आ जाओ। 30 कॉल कर लेना आके 30। So anyone with the answer?
First one is 0.0129.
0.0129. I am getting it around 0.141, and second one I am getting 0.337 meter. That is okay. If you are getting nearly 0.14, 0.13, you can check the calculation. So these are the response, or we can write it into the mm, 141 mm on 337 mm, or the in the centimeter, like the 14 centimeter and the 33.7 centimeter. So you can see how as the speed is increasing on the bump, how much the response is the vehicle is experiencing. For the 10 kilometer per hour, it is experiencing 14 centimeter, and for the 20 kilometer, it is experiencing double around. So now the force in the spring, it is asked only the force in the spring, not in the overall. So that is the K into U naught. So that would be coming out to be for both of them. K is the 140 into 0.141, and another is the 140 into 0.337. So the force in the spring is coming out to be 19.7 for the one, and the another is coming out to be 47.2 kilometer. That was the case. In the part B, you need to find out the maximum acceleration. Okay, so for the maximum acceleration, you have the Umax, we have calculated as a UG dot divided by omega n square into RD. We have done it. And U double dot max is what? Omega n square time the Umax. Okay, so if I will get Umax double dot, then it would become UG double dot into RD, and UG double dot into RD, what was that? That was the pi by TD square into UG naught into RD, into UG naught, maximum response only. So if you will put it, then you will get it UG naught pi by TD square into RD. So you have the UG naught as a 0.15 pi over pi square TD you have, and RD you have. So for both the cases 10 and 20, you have RD is equal to 0.9575 and RD is 0.574. So if you will calculate U maximum acceleration, if you will put the value, TD was that 0.36 and 0.18. So you will get the acceleration as a around 11 meter per second square and then 26 meter per second square. So in this also we can see like how the passenger will feel discomfort on the breaker if our speed is high. So our system like should be designed like that our passenger should not feel the discomfort. So these are the observations from this question. So this was the simplest question, simple question. These kind of questions we have done, so that's why I didn't discuss in the detail. Still you have any doubt you can ask in this question. Anyone? If not, then we have another kind of pulse. I will give you the answer directly. You can solve it. So in this, the pulse is given the response. The pulse function pt is given as a p naught e raised to power minus et is given us. So we need to find out the response of the system ut. So ut for this undamped system 1 over by Duhamel integral 1 by omega n 0 to t p tau sine omega n t minus tau d tau. So only thing you need to do put the value of, instead of p tau you need to put the value of p naught e a tau sine omega n t minus tau d tau. So you can solve it. This is a simple integral, and if you will solve this you will get ut is equal to p naught by k, into 1 by 1 plus a square by omega n square into e raised to power minus at plus a by omega n sine omega n t minus cos omega n t. Only thing you need to solve this integral only. So that will be over this one. Is it okay? And to find out the steady state response, so after some time by this term e raised to power minus et dies out. Okay, so my ut steady state will become p naught by k into 1 plus a square by omega n square is a by omega n sine omega n t minus cos omega n t. So if I need to write the RD value, maximum response, so that would be the 1 plus a square omega n square, and the maximum of this will be given by this square of this term, and that is the 1. So that would be a by omega n square plus 1. So if you will simplify this, you will get this 1 over 1 plus a square by omega n square RD. This is your steady state response solution. So is there any doubt in any of the questions? We have solved 8 problems. So if you are facing any doubt in any problem, you can discuss it here. Can my Duhamel integral is applicable for the nonlinear system also? Anyone?
What, sir?
Is my Duhamel integral procedure is applicable for the nonlinear system also? Can I use that? Because Duhamel integral is a like a superposition method kind of thing.
Yes, it is actually linear system method of
Yes.
superposition.
So it is a method of linear superposition. So these are the like some simple questions. Sometimes they ask for the 1 mark or something else. Kind of this is applicable. One kind of question you can do that, like if my pulse duration TD by Tn is less than 0.25, then what parameter will affect my response? Whether it is shape of the pulse, whether it is the area of pulse, whether it is the both the shape and area, and the none of about those kind of things. So in that, the area of pulse will be the essentially to control the response.
I didn't understand the Duhamel integral, why it is not applicable for nonlinear systems. The reason you told.
Because that is a superposition, linear superposition, that the formulation of these that equation I ut is equal to I by 1 over m omega n integral 0 to td p tau of
Hmm.
something. So that was the superposition, like a superposition of the pulse by pulse, like for the first pulse with second pulse then third pulse. So that's why it is not applicable for the non-linear. It is only made for the linear.
Okay.
So are you facing any doubt in the assignments week 5, or it is simple? I think that was the simplest one assignment. Any doubt, anyone? Or should we conclude the session? If you don't have any doubt, you can leave it. We can meet in the next Tuesday. So in that, our some earthquake kind of things will start from the week 6. So if you have any doubt or suggestion, you can give it here. I know today that one question was very long, so you may get bored, but that's okay. That needed because the derivation. If you anyone has no doubt, you can leave it. I will be there up to 8.
Thank you, sir.
Okay. If you have any suggestions, you can give me.